Welcome back to Kamal Kunj Home Academy, Encounter with Mathematics. In this session, we will discuss Intercept Theorem. According to this theorem, if three parallel lines intercept equal segments on one transversal, then they intercept equal segments on any other transversal. Here given three parallel lines L1, L2, L3. The transversal T1 intersects at A, B, C. What is given? Three parallel lines L1, L2 and L3 are cut by transversal T1 at A, B and C such that AB is equal to BC. Another transversal T2 intersects at D, E and F. Another transversal T2 T2 cuts L1, L2 and L3 at D, E and F. To prove what is to be proved? This line segment intercept on T2, DE will be equal to EF. To prove DE equal equal to EF. Now there are three possibilities. Proof. L1, L2 and L3. T1, A, B and C. T2, D, E and F. This is first, second, L1, L2 and L3. T1, A, B and C and T2, D, E and F. This is third possibility. There are three possibilities. First, T1 and T2 are not parallel and B is not equal to E. Second, T1 and T2 are not parallel but B is equal to E. And here T1 and T2 are parallel. So there are three possibilities. There are three possibilities. Number one, T1 is not parallel to T2 and B is not equal to E, this case. Second, T1 is not parallel to T2 and B is equal to E, this one. Third possibility, T1 is parallel to T2, this one. So we have to prove that DE will be equal to EF. D and E will be equal to EF in each case. Here, case 1. Case 1. This one. T1 is not parallel to T2 and B is not equal to E. B and E are different points. Then there exists a transversal T3. There exists transversal T3 parallel to T1. Intersects L1 and L3 at let G and this will point H. At G and H. H. And passing through E. Draw transversal T3 parallel to T1 through E, intersecting L1 and L3 at G and H. Now AB is parallel to GE because L1 is parallel to L2, so AB is parallel to GE. AB is parallel to GE and AG is parallel to BE because L1 is parallel to L2, so AG is also parallel to BE and AG is parallel to BE. This implies that BEGA is a parallelogram. Parallelogram. Since opposite sides are parallel, so BEGA is parallelogram. This implies that AB will be equal to GE. AB will be equal to GE. Opposite sides of a parallelogram are equal. Opposite sides of a parallelogram are equal. Then here BE is parallel to CH and BC is parallel to EH. Therefore, CHEB is a parallelogram. BE is parallel to CH because L2 is parallel to L3 and BC is parallel to EH. Because T1 is parallel to T3. This implies that CHEB is a parallelogram. Parallelogram. Hence, BC will be equal to EH. This implies that BC is equal to EH. Now let us consider triangle DGE and FHE. One-to-one correspondence between DGE and FHE. DGE and FHE. Angle DGE will be equal to angle FHE, alternate interior angles. Angle DGE equal to angle FHE. And this angle GDE, this angle will equal to this angle. Angle GDE will be equal to HFE, angle HFE. And here GE is equal to EH, because AB is equal to BC and AB is equal to GE and BC is equal to EH, therefore GE is equal to EH. We have GE is equal to HE. Therefore, triangle DGE and FHE are congruent. Therefore, triangle DGE is congruent to triangle FHE. This implies that DE equal to FE. Equal to EF. Corresponding parts of congruent triangle. See the case 1. D is equal to A true. Now case 2. Second case, case 2. Let us consider one-to-one correspondence between triangle DAB and FCB. DAB and FCB. Here we have angle ABD is equal to angle CBF. Vertical angles are equal. Angle ABD equal to angle CBF. Here it is angle side theorem. Angle side theorem. In this case, angle side theorem. Here angle A, this vertical angles are equal. Vertical angles are equal, and this angle DAB will equal to angle FCB. Alternate interior angles. Angle DAB will equal to angle FCB. Alternate interior angles are equal, and AB equal to BC, AB equal to CB given. CB, it is given. Therefore, triangle DAB is congruent to triangle FCB by angle side angle theorem. Angle side angle theorem. This implies that DB is equal to BF. DB is equal to FB. This implies that DE is equal to EF. Okay, since B is equal to E. So in this case also we have proved that DE will be equal to EF. case 3, third case. Case 3. Transversal or parallel. T2 transversal is parallel transversal T1. Therefore, BEDA will be a parallelogram because AD is parallel to BE and AB is parallel to DE. Therefore, AD is parallel to BE and AB is parallel to DE. Therefore, BE DA is a parallelogram. This implies that AB is equal to DE. Opposite sides of parallelogram. Opposite sides of a parallelogram are equal. Similarly, this CFEB is also a parallelogram. BE is parallel to CF and BC is parallel to EF. Therefore, CFEB is a parallelogram. CFEB is a parallelogram. By definition of parallelogram, if opposite sides are parallel, then it is parallelogram. This implies that BC equal to EF. Therefore, DE is equal to EF. Since AB equal to BC is given. So, in all the three cases we have proved that DE will be equal to EF. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.